Welcome to our Weigl control tutorial. In front of us are 3 PD6 Nanotech motors for setup. We'll initiate this by launching the plug-in drive studio by Nanotech. We are operating in the admin mode for optimal performance on Windows 11. I've got one motor connected. Displayed here are the connections for all 3 motors. You can reassign connections via USB. Proceed by selecting Next. Once the device details like devices, serial number and firmware version show up, click to continue with Next. Select your COM port. It's recommended to press refresh for the latest configuration. Choose COM5, then confirm with Finish. A pop-up will acknowledge the successful connections. After selecting COM5, my motor is now connected. Moving on in the Setup menu, the Object Dictionary is actively syncing and downloading motor data. Please note, this is our initial motor setup. Key settings to update are max current and nominal current. Following the user's manual, these currents have been reconfigured for optimal motor performance. In auto setup, should motor connection fail, ours is successful, go straight to the setup firmware section for troubleshooting. Here, a firmware flash might be required if the issue is due to the outdated firmware. As all motors are currently up to date, a firmware update is not necessary. Proceeding with the auto setup will trigger a warning that any unmodified data will be purged. Confirming this will clear all previous settings that haven't been updated recently. Typically, you would apply and save before starting. However, since settings are correct, we'll proceed without saving again. Next, a confirmation message indicates completion, followed by a save and restart. This triggers a motor restart, after which we'll move to the operational checks. Target position 0 is set here. Optionally, adjust the homing offset if needed. In the profile, I've kept settings unchanged as they were originally correct. Nominal current was preset during initial setup. For homing, we can use methods like block, Hardstop for a hard reset. The minimum current for block detection is configured to 600 mA to facilitate a Hardstop homing. To execute Hardstop homing, activate the negative limit switch block, then use method -17, which grays out all other options, as it exclusively pertains to method -17. Should any settings, like the encoder index hitting after the switch, be altered, it transitions to an alternative method. Yet our goal is to establish a block using the negative limit switch. Next, we will power on and activate the homing mode, and then we initiate the homing sequence. The motor will now operate until it encounters a blockage. And as observed, the homing process concludes successfully. There is no need to alter motor ID settings, which are located on the rear dial of these Nanotech motors. Hence, ID1, ID2 and ID3 are also stated up front on the motors for better clarity. After completing homing, it's possible to close the window. Keep in mind the method -17 as we need it later for homing. Next, in the configurator with the ProCommander AX, ensure to declare the connection of the 3 motors. Establish the CAN node first, followed by configuring the Nanotech driver, which is critical to run all motors on ProCommander AX. Reboot ProCommander AX to save all settings. Now, individually initiate homing for each motor, starting with motor number 1. Repeat the process for each motor. Stop it, and once homed, it should display finished motor homing. With motor 1 homed, ensure motors 2 and 3 are also homed. Then AO2 for motor ID 2, also with method -17, and then you already see the motor is beginning with the rotation. Having completed homing for motor 2, we advance with AO number 3 for the third motor and repeat the entire process. One benefit of CAN Nanotec motors are their preset baud-rate, which are 1 megabaud on all CAN Nanotec motors. There is no need to configure it to 1 megabaud, as our baud rate from our system already matches the 1 megabaud from Nanotec. In the output tab, analog channels 1, 2 and 3 are visible, showing the motor's movements, and this includes the adjustments for motor 3. One could also apply the fade function for smoother motion, making the motor's travel more controlled, as it requires the defined time to fade to the intended motor position. Please proceed the programming in the software of your choice. In this case study, we are using Conductor, where we created a control sequence. Using Add Device, we can assign ProCommander AX to the timeline. Click on ProCommander AX, then assign 3 analog channels to control your Nanotec motors 1 to 3. And it's crucial that the UDP output aligns with your network settings for accurate communication. This configuration works for me, as my devices are recognized with IP101, a standard setting for the ProCommander AX. Set the locator to position 0 and start the replay, and you see the operation of the motors accordingly to your programming, since all channels in the timeline are identical. All 3 motors will move simultaneously and at the same speed, though not necessarily from the same starting point. They will run in sync, first in one direction and then in the reverse directions slightly faster. That concludes the basic programming and configuration steps for Nanotec motors. If you require more materials or information, check out our website on weiglcontrol.com. Thanks for watching.